So today we're going to go over the virtual titration lab. Now, titration is a very important tool in chemistry because it allows us to find the concentration of an unknown solution. Some of the mathematics involved, however, is a little bit, we haven't got quite to it yet in our course. Maybe in your course you have already. And what it involves is using the mole. So here I have a mole. Besides being a furry little creature with poor eyesight, it also is short for molecular larvict, which stands for the weight of the molecule, or translates from German as the weight of the molecule. And so here I have a molecule of water. What that's going to allow us to do then is bridge the microscopic world of atoms and molecules to the macroscopic world of grams and liters. The masses on the periodic table of the elements, there we go, are all based on how many grams it takes to make a mole of that substance. Now, I have also made a data sheet, so this is available on my Google Classroom. If you're watching this and you're not actually in my class, just send me a message or comment down there in the comments, and I'll be more than happy to email you the data sheet so you can keep track of it as I go through the lab. So this company that we're using is called Smart Sparrow, and it's Smart Sparrow Titration 1. So we're going to find the concentration of an unknown solution of hydrochloric acid. Alright, so here is our virtual lab bench. This is our digital burette, so it'll go drop by drop and keep track of how many milliliters it takes to titrate our samples. Here's our pH meter. Make sure you don't forget to put the electrode in there when we do that. Here is our KHP. The KHP is potassium hydrogen phthalate. It has a molar mass of 204.233 grams per mole, which will be given to you further along as you go through and do the calculations. And here it'll tell you that as well, so you don't have to write that down, although it is on the data sheet that I just showed you in the introduction, and I will use that later on in the lab to show you how to do the calculations. So the first thing that you want to do then is open up your electronic balance, go to your supplies, get a weighing boat, place the weighing boat on the electronic balance, close the door. We want to zero that out, so we hit the tare, T-A-R-E key, open it up, and I'm going to scroll through here until we get to the point at which it says to measure out the KHP. I've done this lab a couple of times, so I can skip through here. Now, as we add the sodium hydroxide to our potassium hydrogen phthalate, the pH is going to start slowly going up. Once we hit this point here, this inflection point, this is the end point. Now, this is a weak acid and a strong base. So what is going to happen is it's going to be a fairly sharp peak here where this is one drop that's going to change it and shoot the pH up that far. If you didn't have the digital pH meter, then what you could do is use an indicator such as phenolphthalein, and it turns from clear in being the acidic solution to pink in the basic solution. So the pH of 7 right here is neutral. So since this is a weak acid and a fairly strong base, the pH is not good. The equivalence point and the end point are not exactly the same. For the unknown hydrochloric acid, it is going to be the end point and the equivalence point are both going to be about pH 7. But all we have to do is figure out how many milliliters we added when it shoots up here, and we want to pick right about in the middle. And we'll do that as we go through and calculate it. So, again, make sure you read through the different parts here. Still in the introduction, so I have to get to measuring out for our data sheet. Alright, so now I'm going to go back to my supplies. I'm going to take the scupula. I'm going to put it into the KHP till it turns blue. Put it over the weighing boat. It says to measure 0.2 grams. So each tap is 0.1. So there's 1 tap. There's 2 taps. Now we want to get this out of the way so we don't accidentally dump more in there. Click record. And for our first trial, it's 0.1970 grams. So I'm going to record that on my paper data sheet as well. Now it does save it on your electronic data sheet up here, and I haven't recorded it. Click next yet, so that's why it didn't show up when I clicked on there. So here we go, and there we go. Good. So now what we're going to do is we're going to actually get this ready to titrate. So I open up the door, bring it over, put it into my 250 milliliter flask, get rid of that weighing boat. We have to, 50 milliliters of water. Now, KHP, potassium hydrogen phthalate, is a white crystalline solid. Most acids are white crystalline solids until you dissolve them into water. There's 50 milliliters. Move it up underneath our burette. Don't forget to put the electrode in. That's very important. And there it is reading on our pH meter. So I can click start, and it's going to drop-wise start adding the sodium hydroxide into it, so that way we can find out what the concentration of our sodium hydroxide is. Now I'm going to fast forward through part of this because it does take a couple of minutes in order to get that curve to go up. Alright, so now that our curve has gone up here, I'm going to go ahead and click stop and then analyze, so that way we can see, and it says it took 6.43 milliliters to reach the inflection point. It'll tell us that on the first one. It's not going to tell us that for every single one. And what you can do is you just cursor over until you find it, and right there's 6.40. 6.50, 6.4, so 6.43 is what they're telling us it is, but you just want to pick a point right in, kind of in between there. And so now that I have this one done, let me switch over to the camera. So now we can see on my printed off sheet, I recorded 0.1970. The volume of sodium hydroxide is 6.43 milliliters. Now keep in mind that this is a virtual lab, not a video lab. Every time you do the experiment and you restart the experiment, you will get different numbers. So just because I got these numbers, does not mean that you are going to get the same numbers. The computer goes through and it changes the lab each time a little bit. So you can't just write down the numbers I get and think that they're going to be the correct answer, because they may not be. Now once we have that trial done, I'm going to take my flask, take it to the recycle bin. I'm going to get down a new flask, a new weighing boat, because the magic number seems to be 3 for titration trials. You want 3 good ones. So ones that are really, really close to each other. And since we're using the same amount of KHP each time, it should take about the same amount of sodium hydroxide. So we do it exactly like we did for the first trial. Close the door. Don't forget to hit record. So this time it was 0.2003. So just a little bit more. I'm recording that on my data sheet. And then again, put it into your 250 milliliter flask. Recycle that. Add about 50 milliliters of water to it. And again, the amount of water really doesn't matter. It's just to make sure that it all gets dissolved correctly. Oh, we got to move my water bottle out of the way. Again, do not forget to put in the electrode. Make sure it's reading the pH, and press start. And again, through the magic of editing, I'm going to fast forward through the part here where it's simply adding it to it, and I'll pick it up again when we get to the titration curve and analyze it. Alright, we've passed that inflection point, so I'm going to stop the titration, and then I'm going to come over here and analyze it. Notice it did not tell us how much we used this time, so we have to measure it out. So there's 6.45. There's 6.6, 6.5. So I'd say about 6.53 would be the amount that we used for this one. So I'm going to record 6.53 on my data sheet, as well as typing it into the data sheet on Smart Sparrow. And if I'm wrong, it'll tell me it's wrong. And if I click on datasheet, you can see mass of KHP, volume, mass of KHP2, volume. And so that is on there if you don't want to write it down on the sheet that I have where you can download as well. And now we do the exact same thing again for a third trial. Alright, now that I have my 3 titrations for the standardization of the sodium hydroxide done, we're ready to do our titration for the hydrochloric acid. So I'm going to recycle my Erlenmeyer flask. I'm going to get a new one out. Now for this one, we're going to use 5 milliliters of our unknown hydrochloric acid. So that's the nice thing about titration, is we didn't know the concentration of our sodium hydroxide. We don't know the concentration of the hydrochloric acid. But by standardizing it with a known amount of a weak acid, potassium hydrogen phthalate, KHP, we now will be able to calculate exactly what the concentration or molarity of our sodium hydroxide is. Come over here and get my pipette, put it into the hydrochloric acid, make sure it turns blue, draw up 5 milliliters, move it over to my flask, again make sure it turns blue, dispense the 5 milliliters, then I'm going to put it back over here on the stand. Move my flask underneath the digital burette. Don't forget to put the electrode in. And then click Start. And by doing this, this is going to allow us to calculate out the exact concentration of the hydrochloric acid. Now, unlike with the potassium hydrogen phthalate, and it had you do 3 trials, the lab is set up that you only do 1 trial to find your unknown concentration. Alright, now as you can see, this peak looks, or graph, looks much different than the last one. This line here, 1 drop shoots it way up, and that's because we have a strong acid with a strong base. So as all of the acid is used up, that last drop shoots the pH way up. And so you can see there's 3.4, there's 3.3, so I'm going to call it 3.35. And I'm going to record it on my sheet as well, so I can show you how to do the calculations. Alright, so now we are on to finding the moles of KHP in trial number 1. Alright, so I printed the calculations down here for you, and again they are on the screen as well. So you can see grams of KHP. So for my first trial, I had 0.1970 grams of KHP. I'm going to divide that by 204.233. So 0.1970 divided by 204.233 gives me 9.6 5 times 10 to the minus 4 power. Now, if you wanted to, you could put that in standard notation as well and have it as 0.000965, and that's perfectly fine. I just chose to write that one into scientific notation. Now, once we have our moles of KHP, we need to record that then also on our electronic data sheet. So I'm going to click right there, and I'm going to type in 0.000965 for the moles of KHP for trial number 1, and notice the units are already on there. And likewise, I have to type in the moles of KHP for trial 2 and trial 3, doing it the same way. All right, now that I have calculated out the number of moles of the KHP for each of these, it's a 1-to-1 ratio that 1 KHP reacts with 1 sodium hydroxide. So I'm going to take my moles of KHP, the 0.000965, and divide it by the liters of sodium hydroxide used. Now, I use 6.43 milliliters, but molarity is moles of solute per liter of solution, so I have to convert milliliters to liters. No big deal. You simply divide by 1,000, and it becomes 0.00643 liters. So that'll give us now moles per liter, which capital M stands for molarity, and it turns out that it's 0.150. And then we're going to record that in our electronic data sheet as well. So right there, concentration for trial number 1, 0.150, and then click next. And it's going to ask you to find the concentration for trial 2 and trial 3 likewise. So I'm going to skip ahead and do those. All right, so now that I have my 3 different trials, I want to average them. So you simply add the 3 molarities together and divide by 3. And it turns out for mine that my average concentration of the base was 0.150. Now it's probably going to ignore that 0, but I'm going to type it in there anyway. And I'm going to record that in my notebook as well. All right, so to calculate our moles of base, what we're going to do is take our volume of the base used, the sodium hydroxide, times its molarity. Now again, make sure that you have both of these in liters. So here I have my 0.150 moles per liter is the molarity of the base. The volume that it took was 3.35 milliliters. So converting that into liters would give me 0.0035 liters times 0.15, and my molarity of my base is 0.000525, which the computer is prompting me to type in. So I will do that, but leave that number in your calculator. So now, in order to calculate the concentration of the hydrochloric acid, we simply divide by how much we used, 0.005 liters. And that gives us a concentration of 0.105. So switching back to the electronic data sheet, I'm going to type in 0.105 and next. Now, this is the discussion question. I'm going to leave that up to you, not give you the answer for that one. Again, I hope that this walkthrough of this virtual titration lab helped you. Again, if you would like the data sheet, it obviously is all on the electronic version as well, but if you want one to actually write down and keep track of everything in case something happens or you can go back and check your work, again, you can send me an email and I'll be more than happy to email you a copy that you can download and print of that sheet. So for Kicked Up Chemistry, thank you for watching, and I'll see you next time.